Welcome to the AMTC 2021 interview series. In this episode, I've been joined by Professor Johannes Schleifenbaum from Aachen University DAP. Thank you very much for joining us today,
Thank you.
Professor. I guess we should really just start out by clarifying what DAP is, which is the Digital Additive Production.
Yeah.
Yes. So if you could just give us a little bit of insight into the mission of DAP and the activities and how you're involved.
Well, actually, DAP is some sort of tautology because it's digital additive production. And if you think of additive as a production technology, or maybe even more as an umbrella for various production technology, those production technologies are digital by nature.
Yes.
You need a CAD model, you need a digital transfer to get finally in the end the part. And therefore, digital additive production is sort of that tautology. You could simply leave it out. But what I wanted to do when I founded the chairs some 5 years ago is to put emphasis on how close those digital and real worlds are connected and how, let's say, important that role of that manufacturing technology is to serve also not only as a production technology, but also as a metaphor for those two worlds. In most cases, we talk about digital twins today. I like to talk of additive manufacturing as the real twin for the digital world, so to say, so to invert that a bit. And that was basically the idea. And that is sort of also the mission statement of DAP. So we try to work at those borders where digital and real world really interconnect. So our main footprint is in the transfer of new AM-enabled design via a 3D data processing pipeline all the way to the product. And we mirror that then with a physical production chain, and that's basically what we do. We try to cover everything from design to product and not too much dig in too deep in each single process, but to stay on that, let's say, value creation process on a digital and on a real level.
Okay, so I'm loving this crossover and the way you're framing that's amazing. And there's absolutely no doubt that the two together are improving efficiency and productivity across the sector. But can you highlight the significant milestones on this digitalization journey for additive manufacturing? What still needs to happen as well?
Yeah, many things. I mean, again, the process is digital by nature. So when it started back in 83, 84, when Chuck Hull invented that SLA technology, why did they do it at that time? That was the time when some 5 or 10 years earlier, the first 3D CAD modelers were invented. So we became literally three-dimensional at that time when we started from a bare scratch on a paper, pen and paper work, and transferred that into the 3D world. And then we realized, okay, now that we have those images that still on a 2D screen are sort of 3D, how can we get this out to the real world? And that was mainly the driver. That time was not additive manufacturing, it was rapid prototyping. So we basically, and that's the drawback from that, it's digital by nature, yes, but we still rely to those interfaces that were given at that time, basically. Just take, for instance, that we still rely on an STL, standard triangle language, a representation of the part. I mean, we have very clever ways to model our 3D parts today, made be either by NURBS or either by voxelized models. But then we throw all that intelligence away at a certain point and step to that old format, let's say. I know that this is the standard and it's good to have standards, but I think it's time to overcome those standards, to get more intelligent in terms of how can we attach more information to the data that we have on a geometrical basis, how can we then use that as also as a container for all the process information through our sensors that we can filter back then and attach it again to the model, and then we are in a digital twin world again. And the interconnection could be way better. And due to some older formats that we still used and that's still industry standard, this is sort of inhibited. If you go from CAD to STL, all the basic information that you can attach to a model in a modern world, may it be a certain tolerance or something, it's lost. It's lost forever. And this is something I think could be very much be better. The interconnection of the machines to a SCADA, to an MES, machine interface system, could be way better. We could use just OPCUA as one standard for machine communication, which is a real standard in the machine tool industry, becoming a standard in AM eventually, but that still is an open field. It's sort of an open pit mine where we have to work on and dig on deep and then finally bridge it somehow. But there are at each and every corner where we look at the digital process chain, there are drawbacks and there's no real interfacing. So again, a short question, long answer. Where are the drawbacks? I think all across the digital chain, there are many drawbacks that need to be overcome to be really able to build up a continuous flow in a 3D data pipeline.
And is this all the issues that you're working on with your team?
Yes, and no, yes, but, and here comes the but, I tend to say no also, but this is not true. Yes, but. The task is way too big for just a single chair or university.
Okay.
So what we do normally is, especially since we have a large footprint in more application-related research than in basic fundamental research, is that we partner up with many companies that are also here at AMTC, with other ones like Siemens, like PTC, like Autodesk, and all those guys that are around that come in more from the digital world. Also newer companies like Dendrite from the US. Yes. We try to connect them with the old-fashioned, let's keep it that way, machine manufacturers and form up teams. And we are more, let's say, some sort of super connector. Okay. And then once we have that picture, we try to figure out, are there any white spots? And then we go precisely for that. Okay. Just to give you a tangible example, we just created an open vector format, .ovf, and it's an open source format. We published that on Git. So it's accessible by everybody in the world, machine manufacturers, private persons, companies, whomever you can imagine. And that format simply enables the description of 3D models along with technological and meta information. So now you could simply just go from the CAD model to the machine, and it's completely open source. So every machine manufacturer can then use his post-processor to hide the data he or she would not to show, but providing information. And that is good since we're a university, we're neutral, we're a non-profit organization, yes. And we publish it then. Whether it will be adopted, we will see. But that is one thing that we're working on, just to make that connections, that super connecting in between all those parties. But it's never been, and it will never be, a task that we can solve on our own. No. Definitely not.
I totally agree. But that's amazing. But I like the idea that you're the super connector. That's a really nice way of putting it. And if you bring more of these players together, then that's how we're going to see progress, isn't it?
Yeah, and the good thing is about it, and that's pretty much typical for the German universities, we are a larger research institution, so we've got about 100 people working on that topics, which is pretty large for a chair. Yeah. And then we do research interconnected with industry, and what we try to do on the basically the same metal, but the other side of the metal, is to transfer that into teaching, so that we try to get the research involved in teaching and try to train the engineers that are outgoing from the university, that they have the latest knowledge. Because normally what we do, of course we do that in base courses as well, we start also with STL because it's the standard.
Yes.
But once we train the standard, well, what do they have to do? Then they learned it on the hard way, and once they're out and a new format is, they have to basically erase it all. So I try to show them both sides of the world. The old one that they can experience in companies, but also the new one that, from my point of view, is coming.
I think that's absolutely amazing. And actually a reoccurring theme from today has been the lack of skills, the lack of knowledge, and getting that into industry and connecting with the universities. Yeah. So, I mean, I know you're a single university, but it's really important, really important. So if we take a little step back then from the sort of focusing in on the digitalization, in terms of some more global issues, two of the big ones are sustainability and climate protection, and I know you have some specific interest in those. Can you just talk about how you see how additive manufacturing can have an impact here in a significant and long-lasting way? And I think that's the key, isn't it? Significant and long-lasting, not just sound bites.
Yeah. You're pointing exactly in the right direction. I mean, we all have a gut feeling that additive can presumably be beneficial for those issues due to lightweight construction, well, let's say, not really 100%, but almost 100% material use, to not wasting all those milling processes existed or produced chips that we throw out of the factory. The problem still is, and we had that discussions also yesterday with some partners from Boeing, with Melissa Orm, with others from SLM Solutions. And what we still see today, and I see also that there is an important role for the universities, there's hardly, at least I don't know them, there's hardly any life cycle assessment or input-output table from the mining till the final product. There are
the production of the final product or the end of life of the final product?
If you really want to take it the whole thing, then actually
go to end of life.
Not really, because the LCA guys, they do not talk from cradle to grave. They talk from cradle to cradle, and the end of the life is then the beginning of new life. So it's not so easy to see where's that cutoff of the line.
Circular economy.
Yeah, right. That's
okay.
making a circle.
Yeah.
So in the end, we have to define some boundary conditions, and there are pieces of the puzzle already exist concerning material consumption, concerning energy input, with some variables. Is the currency that you receive from a brown coal powerhouse, or is it from a solar panel, or where is it from? These are the factors that you have to model and you play with. But what universities still have to do is to be some facilitator for accessing that. Let's call it cradle to grave, so end of life chain, and really find measures for that. There are currently 2 projects to be started, I guess, next year, which are taking that. It's more long-term run. It's, say, 3 years, 4 years projects that we're planning and hopefully doing next year, or starting next year. There are some advancements as well. We recently, as the ACAM, the Aachen Center for Additive Manufacturing, where my chair is part of, joined the AMGTA, so the Additive Manufacturing Green Trade Association.
Yes. Sherry.
Sherry Hamill.
Yeah.
And we try to join forces to provide research power, because we are facilitators. We want to find mitigation strategies and be that super connector that aligns various interests along that chain, but in the end to build a reliable model where you can say, okay, if you compare product A and product B, manufacturing method A, manufacturing method or process route, as we sometimes call it, B, we can calculate euros, but can we also calculate then carbon footprint, resource consumption, name it.
Yeah.
The holistic view on that, it's still missing from my point of view, to be honest. We stick to that gut feeling that there is positive effects. There are puzzle pieces that show that within those puzzle pieces there are beneficial effects, but we did not elongate that to the whole chain.
Okay.
That's ongoing, missing.
Okay.
Desperately missing.
But you're going to take steps down that route?
Yeah. But it's not only us. To be honest, of course, there are many players in that market, also partnering up with other universities. I know that there are ongoing projects in TU Munich, which I just recently talked to. There are projects all around the world. So it's not only us. We will see. It's a bit of a competition as well. But in the end, if we align right, we will find
competition can drive the impetus of it, which is a good thing.
Exactly.
We're running out of time here, so I think I will say that I'm going to look forward to interviewing you next time.
You know that I'm used to 90 minutes lecture, so I'm always in that scheme.
No, it's just slightly shorter than that. Okay, thank you so much for your time today. And
thank you for having me.
Welcome.
Cool, thank you.